Hi everyone, welcome to miniKanren Advanced Hangout number something. I'm not sure what it is. Don't have an agenda today, and I guess I know that there's some interesting researchy things going on in the miniKanren world that maybe people want to share. If not, if people have topics they want to talk about or problems they want to share, let us know, or email me, or update the GitHub repo. Otherwise, I guess we'll kind of, seems like we're losing a bit of steam in terms of people showing up or the topics. When that always happens over time. So, maybe we'll go from once a week to once every other week or something like that. Just depending on demand and topics we have or whatever. So anyway, we were just talking about sort of doing machine learning and miniKanren, maybe for synthesis or for looking at properties of miniKanren code or whatever. And seems like a number of people are starting to think about this, or have been thinking about this in the miniKanren space, and now some people are actually working on it. So Daniel was just talking a little bit about reinforcement learning and how that might be used. So anyway, sorry. Please continue, Daniel, or maybe you can back up and give a little context to what.
Sure, I can try to give a little bit of context. So one of the, I guess I can sort of take a bigger step back. When I first saw miniKanren, the program synthesis stuff really interested me because it was the first time that I had seen a system that was capable of doing that. And running my own experiments in the intervening years up until, I guess, 2015, I realized that most of the really interesting problems that I could solve were too big to be solved by the search strategy that had existed at the time. And I also observed that the search strategy basically had certain properties were not present. Like, it has no ability to remember things that it has experienced before. And so it has no real way of prioritizing the search process, which clause to explore, in order to direct the search process towards more interesting outcomes in terms of outputs of the system. And so around that time, I started getting into modern statistical machine learning and sort of trying to figure out a way to give it memory so that we can take advantage of previous explorations to guide the search and prioritize the search in ways that are useful for solving particular problems. And so on that end, the problem seems most similar to a reinforcement learning system in the sense that the search process you can sort of model as an agent that is acting in an environment which has a set of actions that can change depending on the state of the world that it's in. And when you achieve a goal, you want to basically perform value attribution and know how significant was each step along the way in this sort of traversal of the search graph to finding that particular to reaching that particular goal. And you may also want to de-emphasize certain search paths that you know are going to lead to a contradiction or a failed unification, so that you can cut off parts of your search branch, your search, or deprioritize certain branches of your search if you know that they're very unlikely to lead to a success. And so I'm basically thinking about ways to put these two elements together: reward the system, have a metric of reward for when you achieve goals, and basically be able to run miniKanren traces, or maybe even give them a fully specified relation where there's no unground variables, but basically have it be like, okay, here's, like, for example, an input to a program, an output to a program, and a program. And perhaps I mark some things as inputs and some things as outputs, and have it generate a speculative trace. Like, this is the trace through miniKanren that would have taken. It knows, it has an oracle to know which way it should go, since all the variables are ground. but you can use that to basically bootstrap the process of figuring out the reward given a large set of examples, which is, I know that is somewhat similar to the work that you were doing for your initial experiments, Will.
Yeah, I mean, what I was doing was very stupid, right? I was literally just counting. I was saying, okay, how many times does this expression appear in this other expression, and bias the search basically by hand to do that.
But I mean, I think that's basically what you're trying to do with reinforcement learning too. You're trying to find a value metric for how to order your exploration of the space. It may be somewhat more sophisticated from the statistics, but I think the same idea basically applies. And so if we have a way of, I think that's like taking these grounded inputs, or grounded queries to the system, but sort of annotating them as saying some of these things are going to be ungrounded in this way. And being able to generate speculative traces through the system using that as an oracle would be a really powerful way for doing this sort of reinforcement learning bootstrapping of the value function. And so there's a bunch of like technical problems that I think you need to get through. I mean, reinforcement learning is still a very active space in machine learning research. And there's all these other problems, like how do you deal with catastrophic forgetting when you're running queries over time and learning over time. But it's definitely a space that I'm interested in exploring, and that's what I'll try to be working on when I have some more spare time.
So ORCID has a beginner question. What is a trace?
What is a trace? So I mean, in my view is, so when we're running a program, a query through miniKanren forward right now, there's some process that we go through if we imagine it as a graph that's sort of specified by the miniKanren clauses. Whenever we go down a branch of a conn that's basically like doing a node traversal, in my view. Okay, you got it. And so I think if we want to, the key insight I think is if we can generate one of these traces from examples, so we don't have to run the query because that can be very expensive. If we have something which we know should succeed in the system, then we can derive this graph traversal path from start to end without actually having to perform the expensive computation on it.
You know, I think one maybe simple example problem, you know, for testing out the sort of learning would be something like quine generation. You know, there are infinitely many quines, and when we try generating quines, we can generate, you know, I don't know, let's say like 100 in a second if we have the small interpreter. But you'll notice that over time, like, it starts really slowing down. And, you know, because the search space is increasing as the term size is increasing. But, you know, when you look at the quines, most of them have the same basic structure. And so it's like, at some point, you would hope miniKanren would be able to figure out, of course it doesn't, but you'd hope miniKanren would be able to figure out, it's like, oh, a quine, you know, seems to look kind of like this, or it has these properties, you know, so, you know, bias towards that in the search, but it doesn't actually do that. You know, so if you could do quine generation where, you know, generating the, you know, 10,000th quine is maybe gets faster than generating the 1,000th quine or things like that, then that would be nice.
Or at least it doesn't slow down as drastically.
That's right. That's right. You know,
and when
it might still slow down because the terms get bigger, but it shouldn't just like, you know, kind of fall off a cliff.
Right. I mean, I also think that even if your machine learning process isn't perfect, or the value function that it gets isn't perfect, as long as it's better than random, you're going to be performing better than the way that miniKanren does right now, unless someone's very careful about how they order clauses for their particular query.
That's right. And that's why I was, you know, doing that experiment. And Michael and I were interested in trying this on the closure code, was, you know, try to figure out, do we actually get a benefit? So because I made a boo-boo in that code, I need to go back and fix it to see kind of what that does to performance. But you know, I guess the thing we found so far that seems to be the case is, like, you know, even with that very crude degree of learning plus, you this optimization for application that's delaying or reordering application or recursion orders that Greg has. Those two things alone seem to give quite good performance. Now I'm cheating a little bit in my code, so I need to undo the cheat and see what that does to the performance. But it seems like that's a pretty good indication that having a strong, that there is a strong signal for the synthesis code, at least for those types of problems. I guess the most interesting thing to me would be if we could do something like an AlphaGo, where we could have, so in AlphaGo, the DeepMind people were able to get versions of AlphaGo to play against each other, and they could just throw massive amounts of computation at it, and it would just like get better over time, right? And to the extent where at least last year, one of the heads of AlphaGo said that they thought it would probably be possible to reach superhuman performance without ever looking at a human Go game, just by having AlphaGo play itself, with no knowledge of any games that it's seen before. And to me, this would be, this is like the holy grail. If we could do something similar for synthesis with the miniKanren stuff, is like, could we come up with an approach where, basically by exploring these traces and learning properties and things like that, over time it could get better and better at synthesis without having to train it on a corpus of 100 million scheme definitions, because we don't have 100 million scheme definitions to train on.
So I think the answer to that question is yes, and I think this gets back to your cheat, your quote-unquote cheat. So I think it's important that if you have a value network that's directing your search, it fundamentally needs to be made up of two components, which is a value network that says how likely is this branch to lead me to a rewardful outcome, but also how likely is this branch to lead to a failure or contradiction in the attempt to find the goals.
Yeah.
And you can train both of those things independently. In fact, you can get copious examples of failures as part of your existing searches, and you can have those things feed back into your d-value network, so to speak, and probably have it automatically learn to avoid certain things. So I think there's definitely a path to doing that sort of self-improvement.
Okay, so I wonder if you had such a system and you never showed it human written code, what sort of programming style it would come up with. It'd be very interesting to see that. Just like with AlphaGo. AlphaGo plays moves that humans wouldn't play.
Yeah, but AlphaGo was bootstrapped with a bunch of human games at first. I mean, most of it's now been playing itself, but I think that's more of just an accelerator, perhaps.
Yeah.
I think in general, one of the sort of really odd things about neural networks, as just a general example, is that they're not convex optimization problems, but yet we still happen to reach things that are probably still local minima that still kind of give you very similar output performance and results. So I suspect that if AlphaGo was trained from first principles as opposed to bootstrapped with a bunch of human games, I still think it would eventually get to something which performs along the same lines as the current system.
Yeah, because most of the human moves aren't ridiculously bad.
Right.
It's that every once in a while, there's some move that a human wouldn't consider, or humans, more likely humans, have considered it and they've rejected it for reasons that are actually not sound.
Yeah, or they've rejected it because it's too complicated to think through the implications of that move, and they can't do it at game time.
Yeah. Well, to me, I'm very interested in this idea of trying to get the system to kind of learn on its own. And, I'd be extremely interested in trying to build some sort of prototype of that.
Yep. So that's what I plan on working on as I have time.
Yeah, we've got a couple other people now who are interested in doing like neural network and miniKanren things. So I don't know. I don't know. Maybe it's worth combining forces, or at least having discussions about this. And my guess is that different people have somewhat different ideas of what to do, because neural networks and machine learning, it's like a big space. But we've got at least, I think, 4 people now who have knowledge of neural nets and who are interested in kind of neural nets, miniKanren. I'd be interested in, I think this is important for going ahead and making improvements. And the other thing is, we don't just have to do things like synthesis at the level of an individual function. We could do synthesis over API calls. We could do synthesis over, like over library boundaries and module, type things where, a lot of code that's written today is basically glue code, where, you have a bunch of library calls you're putting together in a certain way. Or, higher order or higher level synthesis. Because one of the things I've been thinking about is, say we get to the point where we could synthesize any 20-line program by example and by maybe property. That would be great, and that would be a great advance. Yet at the same time, if you gave such a tool to someone, that doesn't mean that they can necessarily write an operating system with it, right? Or StarCraft with it or something like that. I mean, you need to know which 20-line functions to write, and that's actually a very difficult problem. And even if you could specify those correctly, just knowing which ones you need to write, if you're going to write a 100,000 line program or a 1,000,000 line program or whatever it is, or a 10,000 line program, or even a 1,000 line program, you still have the issue of, which 20-line functions am I going to put together? And so that's another question is, can we pose some problems? Is there something like an architectural level Barlaman, if you want to think of it that way, where, part of this has to do with like, how do you actually design a program that's large, that's not just a couple of functions? What's the right way to think about it? What's the right way to do design and so forth? Or, maybe this gets into the realm of things like case tools, that kind of thing. And then, the Programmer's Apprentice project at MIT was very much about this sort of thing, where, you would have high-level specifications of the code, and, so if we could do the humans kind of driving it to some extent, but, the system can fill in details or point out inconsistencies and incompatibilities and stuff like that, and do some synthesis, that would also be really helpful. Okay, my thought is to synthesize more programs. The solver needs to understand more concepts and programming techniques. Yeah. For a Programmer's Apprentice, they had this idea of cliches. So that was where the work really started in the mid-70s. They have these programming cliches, which I guess are kind of like idioms, or patterns or whatever. And they would try to teach the Programmer's Apprentice more and more of these cliches, with the idea that either the programmer could talk in terms of the cliches, or you could use the cliches for synthesis or things like that. But having higher levels of or larger units of reasoning about, besides just the expression level, that kind of thing, right? So right now with the relational interpreter, in some sense, the relational interpreter encodes everything about scheme, but in another sense is like it doesn't encode anything beyond the expression level. It doesn't have any notion of how you would actually try to build up a real program. So maybe we synthesize UML diagrams or something like that, or I don't know kind of what the right bigger levels of abstraction are, but that's something I think that to start thinking about is, as we get better with synthesis, kind of ask ourselves, if the synthesis at a small level was basically solved or largely solved, what would you do, that's bigger scale? Yeah, it sounds very interesting to be able to synthesize programs in terms of abstract functions, of specifications, instead of concrete ones that we execute. Yeah, so you could talk about like an interface, right? We could talk at the levels of interfaces and then synthesize implementations of the interface. Or you can talk at the level of algorithms and data structures, or modules, or patterns, or cliches, or whatever it is. But that's something I'm starting to think about. I'm reading that Programmer's Apprentice book, and I'm interested to learn more about what sort of approaches they took. And they actually were developing some tools. They also had like a design apprentice. So there's a Programmer's Apprentice, but they also had like the design apprentice to try to capture and reason about design information as well. So I guess that's the other thing, is that one good thing about our approach is because it's based on search and constraints and encoding something like an interpreter or a type inferencer or something that can execute rules. That's a very generic idea. So we could have higher levels of abstraction. It doesn't just have to be at the low-level code level. So maybe we have high-level concepts that we can also encode as a relation or whatever, or do synthesis over or search over. So part of that is like, what's the encoding techniques? And so Programmer's Apprentice, they were trying to figure out how to encode this sort of knowledge in a way that you can reason about it executably.
That is the big question after all.
Yeah. And of course, I think, for anything in a foreseeable future, you're still going to have humans involved. But, how do you have the human communicate with this tool so that the tool can basically take care of low-level details or find inconsistencies or, suggest completions or do some synthesis or whatever. So, okay, so you think that reinforcement learning is a promising approach, and so I mean, I've read a little bit about reinforcement learning, but I'd be curious to hear if you have. Okay, can you explain kind of the basic ideas and what Q-learning is or whatever, and like how this might fit into the miniKanren things? I've got a very rough idea of what some of the ideas are, but I don't. I haven't put them all together in my head.
I mean, basically, reinforcement learning at its core is maximizing reward given a sequence of actions over time in an environment that may be non-deterministic or have other actors in it. And the way that I model miniKanren search as basically a reinforcement learning problem. The difference, I guess, is there's not really like an explicit graph in a miniKanren search. It's implicit as because of like the way that in miniKanren is implemented, you're basically pulling from these streams.
Yeah.
But the way that I've conceptualized it in my mind in order to understand it is basically viewing it as graph search.
Okay.
We
have, by the way, implemented explicit graphs. Michael Ballantyne's done this.
Yeah, it was much slower, if I remember correctly, right?
It was slower.
But I still think that might be a better approach, at least for fitting it into a machine learning space. Because then it basically it fits the same form as reinforcement learning in the sense that I'm an actor, I'm in the world at this space. These are the actions that I have available to me, i.e. what are the clauses that I can expand upon from where I am in this place. And eventually I hit some resolution. Either I've hit a unification that results in a contradiction and a failure, which I want to avoid, so it's a negative reward, or I hit something which satisfies the query, in which case that's good, and I want a positive reward. And then reinforcement learning is fundamentally about attributing the value of that reward to which actions were responsible for it. And so I have a trace of decisions that I've made as I've been traversing this graph, and I want to give each of those decisions some small amount of that reward, and that reward is contextual. So I'm not just at a point in a graph, but I'm at a point in a graph where I take into account all the previous decisions that brought me to that point as well. And so you're just trying to distribute that reward over all of those contextualized decisions with the hope that you begin to determine patterns on how to act and things that are most likely to lead you to reward behavior. And so that's basically what Q learning is about.
So how would it work for sort of miniKanren learning on its own? Would you have to generate input-output examples, and would you sort of like say, hey, here's an input and here's an output, and here's a whole bunch of those. Try to come up with a function that matches that? Because if you do it that way, maybe there's no reasonable function that does it. Maybe you just have to enumerate all the cases or something. Or maybe you end up with these like kind of bizarro programs. Maybe 99.9% of all the programs that you're sort of looking at are these weird things that a human would never care about or write. Or maybe the learning is such that it's learning basically how do you get from here to there, and it doesn't really matter if the programs it's learning on are kind of weird. They're also the same reasoning is applicable to the programs we care about.
I mean, I think that gets to the question of generalizability. And also this question of macro sort of level architectural design patterns that the thing might learn. But I mean, ultimately, yes, you are learning how to get from point A to point B. You just happen to be learning point A and point B being me incrementally constructing a program. And I mean, that ultimately seems like the problem that you're trying to solve. Like we don't, as humans, a program doesn't just fall out of our head. We fundamentally think about it in terms of pieces. And we've had to learn how to build those pieces and know what context in which they're helpful. And I think that's fundamentally the sorts of problems that this tries to learn. This approach tries to learn.
So say you learn, did some learning, and it worked pretty well. So how would that integrate into the miniKanren implementation? Would it be similar to what we did with that crude learning, the crude counting that I implemented by hand? Would it be something like that where you're just biasing the miniKanren search? Is it sort of like, in the interpreter, you have to make a decision about which clause to go down next, or which expression to try, and so now the reinforcement learning would inform that operation? I
think that's the idea. You, in addition to providing your query, you would provide some sort of a intuition context, maybe. I don't know what we would call it. But it would contain whatever metrics we use for computing a value function for our search in a new query. And then that would guide the search and prioritize the expansion of particular rule sets when trying to satisfy this new query. And if it's a good context, then we get better results. If it's a poor context, then maybe we don't perform any better, or we perform worse than the original search strategy.
So the context might include, the forms outside of it, or the sibling expressions, or something about the input and output examples, or something about a property, or things like that.
Well, I mean, I think the context would in this, at least in the formulation that I'm thinking about, would basically be the neural networks for determining value.
Okay.
And then you would basically be applying them. You'd be doing inference over them at the query time, basically at every choice point in your clause to determine, okay, which way do I go down first?
Okay, so I'm not sure I'm completely getting that. So we're somewhere in the computation. We're trying to synthesize something from
let's say, okay, we have an ungrounded variable which represents the program, for example.
Okay.
And we are at the conD of evaluate, and we need to decide which way to go first.
Yep.
And so the value network would weight like lambda or something highly, or def if we have top level globals. And then we basically go down that pathway first because that's what the value network says is most likely to give us a reward. And maybe there's other clauses that it's de-weighted and things are very low priority, and so that's taken into account into your clause sort. And so we go down that path, and then we end up in a context. Now we're within, say, a lambda, and we know that we need to create the variable bindings. And so the value network will highly value creating a list which contains symbols inside of it. And the context of that, the fact that we're inside a lambda and maybe a body clause, will be taken into account by the neural network.
Okay.
And I think like how you take into account that context, I think is still like, I'm not exactly sure how to do that, but I think it would take there's a subfield of machine learning called structured prediction. And it uses methods like attention, where it can sort of attend over parts of a data structure and sort of scan over it selectively and prioritize what parts are important to it. It's used in, for example, image captioning, where the thing will attend to different parts of the image while it's synthesizing textual output.
Okay, so sort of like where a human would look in the image. Sort of.
Yeah, it's like maybe I'm looking at a picture of a bird flying over a lake, and first I look at the bird, and then I say something about the bird, and then after I'm done doing that, then I attend to the lake, and then I can say something about the lake.
Okay.
And so there's the subfield of structured prediction, which is studying this problem, and attention-based methods seem to be working pretty well there. And so I suspect we would be able to have attention metrics that analyze the substitution and maybe some other representation of where we are in the graph. And I think the graph should be something that's explicit, as opposed to most of the miniKanren implementations where it's not, so that you can attend over it in a structured prediction fashion in order to give context to your search. Okay,
so I guess one thing about the explicit tree or search tree or whatever is that, you know, the tree might be infinite, and so we're only building up the parts of the tree that we've seen in the search so far. Is that okay?
Yeah, I think that's totally fine. Okay. Because obviously you can't enumerate an infinite graph, and most of the really interesting miniKanren queries are over infinite graphs. So yeah, okay. I think you just have to solve that.
I mean, I think if you implement it with the data structure, I mean, first of all, maybe we can do it more efficiently, but it seems like you should have a constant overhead. And so say it's 10 times slower, who cares, or even 100 times slower. If the learning makes it faster over time, then you're ultimately going to win.
Yeah, I mean, it's a question of even if you have a quadratic overhead for keeping track of all this stuff, every node that you traverse is an exponential.
Yeah.
So if you can constrain that more efficiently to things that are likely to result in good answers, then your branching factor is much lower, and so you're lowering your exponential. Well, I mean, you're not lowering your asymptotically, but you're lowering it in practice.
Yeah, I mean, you know, so another thing that I've been interested in from search standpoint is in chess. There's been a remarkable progress with chess engines in that, you know, I know someone who he's writing his own chess engine. He's really into that. And he says, I think it's Stockfish, which is, you know, maybe one of the strongest, if not the strongest engine right now. He was telling me, I think for Stockfish, that the average branching factor for Stockfish is less than 2. That, you know, so the heuristics are so strong, and, you know, the basically they can usually pick one branch to go down. And because of this, they can go extremely deep.
Yep, and deep wins.
Yeah, deep wins. If you can go a few ply deeper, then you're just going to win. So anyway, you know, that's kind of a remarkable demonstration of that sort of thing. Like, you know, and the other thing is, you know, even if you might have a fairly high branching factor because you have lots of scheme expressions that maybe your interpreter can handle 50 possible scheme expressions, let's say. Then, you know, if you have a strong enough signal, in practice, your branching factor may be 2 or 3 within a given context. The others may be very, very unlikely to occur. So.
Yeah, so I mean, that's why I think this approach is promising. I mean, I can also draw on analogies. So when I was in graduate school, this was, 2009, I was taking a computer vision class at the time. And this was before the Alex Krasinski paper on using convolutional neural networks for ImageNet that in 2012, which totally set off the deep learning explosion. At the time, the most sophisticated algorithm for object localization and recognition was SIFT. I don't know if you've heard of that. Basically, it's a scale invariant feature transform, where they would basically have graduate students or experts in the field, shall we say, come up with basically convolutional filters by hand to look for different types of objects. And so it was remarkably effective, but it was very, very labor intensive. And the insight for me when I was looking at the ImageNet convolutional neural network approaches is basically, well, they're taking the graduate student out of that equation by learning these convolutional filters from their data. And I can kind of draw a very similar analogy to SMT solvers and SAT solvers like Z3, which have a huge library of heuristics to guide their search process so that they can produce results that are fast and interesting, but they're all hand-tuned.
Yeah.
And I suspect that there's a similar gap between 2009 and 2012 as there was in computer vision, as there is here. The same properties is emerging where we can get really interesting results in a very labor-intensive way if we do manual heuristics. But I think we also have the tools in place now from the statistical machine learning side where we can achieve machine-derived heuristics that may be even better than the human-derived ones in these problems, where we don't need someone to sit down and spend several months coming up with them.
That's right.
And I suspect
you could also. Oh, sorry. Go ahead.
Yeah. So sorry. I mean, I suspect that if we're right, if my intuition about this is right, then we could have very easily a big explosion where we can solve these sorts of problems of synthesis and context and abstraction in ways that we couldn't have imagined before. And so that's sort of why I'm super interested and passionate about this stuff. But yeah.
Well, so am I. I think this is really cool. I mean, it's like finally the miniKanren stuff is really starting to get fun. It's like, I mean, it was fun for a long time, but now it's like, okay, now it's like really interesting. It's like, oh, maybe this actually, could work.
Yeah, it's just my background in statistical machine learning is sort of still so early. I mean, I really got into it at the end of 2015, so I guess about a year and a half of doing this pretty intensely, while working full time in not this area. So, but I definitely saw the potential of this approach when you were doing your earlier miniKanren videos. It just took me a while to get to the point where I could actually see the path on how we might actually build this using these statistical machine learning approaches.
Well, I think the main thing is if we can get around the corpus problem. Because part of the problem right now is that there's just not that much scheme code or even racket code online.
That problem doesn't actually worry me that much, to be honest. I mean, I think because by running queries in the first place, you're generating more trace data that you can feed into this learning model. And I think because of the fact that there's exponential branching factors, just running a query and having to, I mean, I know we're not really actually backtracking in miniKanren, but sort of the moral equivalent of backtracking if we have an explicit graph approach. The fact that you do that's every time you do that, you're learning something.
That's right. And like quines, for example, they're infinitely many quines, so we can get as many quines as we want. So in that sense, that could be a corpus of things like that.
Yeah.
Programs that we can generate.
And I mean, I think if we're sufficiently ambitious about it, then I mean, think about the process that a student goes through as part of getting an undergraduate computer science education. There's a certain set of sort of really salient examples, like quadratic sorting, and then introduction of things like merge sort, that's log linear. And I think if you could introduce these things to a system that had enough statistical capacity to capture larger patterns from them, maybe you don't need that many examples. I mean, maybe you need a couple of these like lighthouses along the way in the search space that are definitely interesting. But if the system has learned to abstract smaller patterns to build up these larger expressions out of, then maybe you actually don't need that big of a corpus. I don't know.
Yeah. Well, I'm eager to experiment with this stuff. So, I mean, is there kind of a simplest prototype that would be able to test out some of these ideas? Is there something like the equivalent of Parliament, or equivalent of even better, like that little experiment I did? I was basically able to do 24 hours of hacking and test out the basic ideas. Is there something like that that's without like kind of boiling the ocean type thing? Is there kind of like a baby step that would give us a little more insight or information, do you think?
I don't know. I'm still very much a novice when it comes to machine learning systems. So I've been able to trick/convince my work to be able to do this some of the time. But I think probably I'm at the point where I'm still doing etudes, I guess, in reinforcement learning and machine learning. So I'm probably not at the point where I can answer that question yet.
Okay. Well, I know some people who are familiar with miniKanren to some extent or another, who are experts in machine learning and neural nets.
I think I should probably write a version of miniKanren that does this explicit graph search. And I know that you have an implementation of it, but I think it would also be helpful for me to just write my own so I have it better conceptualized in my head.
I don't think it's that hard to do.
No, I mean, it's just, I actually don't think I've ever written a full implementation of miniKanren, so maybe that's the first thing that I do.
Yeah, that's
and put in the appropriate hooks to, I mean, I think maybe the first really big step that I can do from the miniKanren side is be able to synthesize traces from fully grounded examples. Because I don't think that's a tool that we have right now, and I think actually that tool might also be really interesting from an educational standpoint about how miniKanren works. Because right now it's like, oh, how did miniKanren produce that answer, and we don't really have a way of answering that question.
Yeah. I mean, our debugging tools are pretty weak right now.
And so maybe that's the thing that I'll try to do first is produce a version of miniKanren that's explicit about the graph and also has the ability to generate these fully grounded traces with annotations saying, if this was not ground, what would the trace look like? And with that tool in place, then I don't know. I mean, I think that's probably the very first step.
Now, I'm not sure exactly what Evan's created, because I know Evan creates something to do with traces, but it might be different. And I think this is also in Smalltalk. So, I think it's good for you to implement it in whatever language you're comfortable with. Because I think, just by implementing it, you're going to have a better understanding than if you just take someone's code anyway.
Exactly.
Yeah.
So I'll probably do it on Clojure because I'm not hardcore enough to be scheming. Clojure would be great because most of the interest in miniKanren is actually from the Clojure community. So, and I know that there's bindings to things like TensorFlow that work with the JVM. They're still pretty horrible, but at least if at some point we wanted to do something with reinforcement learning, then there's at least some ways to hook up to that.
Yeah, that's a good point. Hello, Michael. I hope you're feeling better. Got still sick. Oh no. Orchid had a couple comments. We could learn the high-level concept of big O runtime. It isn't only training the order of Conde clauses. You've got an actual new mental tool. Are you talking about the learning aspects, Orchid, or are you also talking about the tracing? Okay, yeah. Yeah, I think if we did, well, okay. So what other things do you imagine we would be able to do with the tool Orchid? So say the learning worked well, and what other applications? I think it would be good to give miniKanren new mental tools like arity, types, big O. Seems a bit hard. Well, Dmitrii has actually given miniKanren types at the implementation level. I'm not sure if that's what you have in mind, but this OCanren version of language is like a typed embedding of miniKanren, and it has some nice advantages over standard miniKanren scheme. So for things like arity and big O, Orchid, are you thinking about at the interpreter level, like the relational interpreter level, or are you talking about things like actually built into miniKanren itself? Like the implementation of miniKanren or the miniKanren language? I don't know how you can do this. We could do this. I mean, with types, I can think of types at least two levels. Like you can have a typed miniKanren, which is like the OCanren work. You could also have, and this is orthogonal, I think, you could have an interpreter in miniKanren, a relational interpreter for a typed language. And so like, in the scheme implementation of miniKanren, instead of having a relational interpreter for a subset of scheme or racket, we could have an interpreter for something like ML or something like that. And so for synthesis problems, having an interpreter, a relational interpreter for a typed language, could allow us to use the types and a type inferencer to, to reason about these sorts of things, like, we get the arity from the types and all those sorts of things. The way I see this, reordering con clauses is like leaving out breadcrumbs to make an animal follow a path. I guess if you do something like Monte Carlo tree search, that's kind of my intuition of Monte Carlo tree search, is that, certain branches you're going down, you're kind of leaving breadcrumbs, and the more breadcrumbs you leave down the path, and the more times you go down this certain path, the more breadcrumbs you leave, which makes it more likely to follow it in the future. So it's kind of like a reinforcement that way. I guess that's the other thing. There are things like Monte Carlo tree search, which are different from the like the deep learning or reinforcement learning, but can potentially be used in conjunction. Like at least the early versions of AlphaGo use that.
Pretty sure even the final version of it used it.
Okay. I've been told that there have been a lot of changes to AlphaGo recently, and I'm not really sure now what the state of how it works is.
I mean, as far as I know, it's still Monte Carlo tree search, but it's prioritized and guided by a set of neural networks, like two different neural networks.
Yeah, so like the Nature paper they had like a policy network, and I forget what the other network was, and then they had the Monte Carlo tree search. But I was told by someone that they've changed some of the details, but I don't know. I know it's gotten much stronger. I guess partly because they've just given it more computational time. But, now it's like, I guess it has an account on the Korean Go server, and just like, or one of those Go servers, and it just like trashed everyone.
Yeah, that was the secret experiment that they ran, not telling anybody. The master.
Yeah.
It actually played. It was the Chinese. I don't do Chinese games very well, but the top Go player in the world actually had played it and got defeated by it before the match.
Yeah.
But I think they threw more compute power at the match than they did when it was just a secret experiment running on the Korean Go server.
Yeah, that's it's kind of spooky. That's just really impressive. Hope that works out well. So Dmitrii, you had a remark.
Yeah, you said something about the debugging search order, and I remembered that I did something like visualization of the search order in the it will be a year and a half ago. I better show this.
Yeah, please do.
It was postponed because my advisor really doesn't like this. Okay, where is it? Screen share, yeah. Share, yeah. This is no, this not no. Which browser? Yes. Okay. So this is very initial version of OCanren. It is compiled to JavaScript.
Can you make that a little bit bigger, the text? Is there a way to do that?
Let's go here. Insert link and zoom. Okay, like this.
All right.
So, original version of OCanren was able to compile to JavaScript, and this is JSON is a kind of tool to compile a camel to not readable JavaScript. So I managed to put everything into this browser, and we can declare an appendo somehow. It is disjunction, conjunction, some empty list. It is not so very familiar. The syntax is not very familiar with miniKanren, but it is kind of the same. It is many expanded macros.
It kind of looks like the microKanren code.
Well, you can say yes. You can declare relations, and you can run appendo and get 3 and 4 should Q and 3 and 4 should make 1, 2, 3, 4. The answer should be 1 and 2. Enter. 1, 2, and empty list. No, 2 consoles. And after that, you can click show the tree and see that it creates fresh variable, fresh disjunction, more variable, more conjunction, some, короче, a lot.
Oh, wow.
I don't know if it would be usable for somebody, but I just remembered that this tool kind of in stagnation, but it kind of exists. And maybe if you are curious to hack this approach.
So what's the URL for that? OS Tapers miniKanren? Okay. Would it be okay? So I guess when it comes down to like visualizing the search tree, I guess one thing is it'd be nice to be able to see. So I guess the thing that's kind of obvious here is that the tree like grows really quickly, right? Kind of goes off the screen. Is there a way, do you think, to kind of summarize that or collapse part of it or to make it?
Yeah, there is pluses, minuses here.
Okay.
So you expand all, collapse all, it works as written.
All right, so let's see. So you got a fresh variable, you have a disjunction. So this is basically a trace, is that right? This is a trace of kind of all the operations happening?
Basically, every time when I do something significant about a disjunction or a fresh, I call a hook to construct a graph. And in the end of the search, I just visualize it.
Okay.
Yeah, this is very much along the same lines of what I was thinking to build.
So what was the technique you used, Dmitrii? So is this like a side affecting output, or are you kind of writing this to a log file or something?
It is side affecting the evaluation.
Okay, so you're building up some data structure that's in memory that you can.
Yeah, it is some graph representation.
Okay.
I think a list of integer pairs. and messages, something like that. No,
So Daniel, is that the sort of information you could use to train on, do you think?
Yeah, I think something along those lines would probably work. Yeah.
so maybe it will be inspiration for some hacking, and maybe will be a maximum output from this tool. But at the moment, it is not usable because most interesting cases is when miniKanren hangs.
That part's true, I guess.
Yes, I think it probably still makes sense to do an explicit graph-based miniKanren search, because at least there you can cut it off and be like, okay, what's the graph look like so far?
Okay, so Daniel, can you recap quickly kind of your idea for Michael?
Well, Michael just asked if it was earlier in the YouTube video, so it should be, yeah. But basically, in a very, very short summary, basically try to. So I know that you and Will have created a version of miniKanren which actually sort of takes the explicit graph search approach. So rather than sort of the polling from the stream analogy, have the sort of the conD choice points be explicit nodes within a graph.
That's all Michael. I can't take any credit for that one.
Okay, well, so you did that, Michael. So I'm thinking build a system that can do value attribution in a reinforcement learning style over that kind of a graph. That's like the very, very short summary of it.
Okay, maybe you have to watch the YouTube
so
video.
I explained it much more thoroughly earlier in the video. So yeah, okay.
But the sort of thing that Dmitrii just showed would be useful for that, or what you implemented. Dmitrii also, like one other cool thing that we haven't really talked about with the OCanren stuff is that because OCanren has this type embedding, it doesn't require, when writing the relational interpreter, it doesn't require absento constraints to deal with closures. So that's a nice thing. And you don't need symbolo or number O. So some of those constraints we have just like go away. They're not really necessary. That's pretty cool. And you can get type errors at compile time instead of runtime. And so there's some neat aspects of OCanren that we don't have in other implementations of the language. And I have a feature request to Dmitrii that I really hope he implements. Make it even better. But anyway, so the OCanren stuff is quite cool, I think. Dmitrii, did you have any questions about performance, by the way, for Michael? Or do you think you understand that pretty well? Or there was a question about the attributed variables, right? Did you have a question?
I think yes. So as far as I'm just, yeah. So, I have some difficulties with formulating it right. So as far as I remember, with faster constraints, disequality constraints, we only check the head of the list of a constraint. So we basically check the list of the constraint, and if this constraint, this pair, still can be unifiable with adding something significant, this constraint matter. So it doesn't sound like we check the logic variable with it seems that intuition that we should only check in the constraints Will, can you help me, please?
Well, I'm not sure I completely understand your question, but okay. So I guess the thing that's driving this is that when Dmitrii implemented the attributed variables for the constraints, it seemed to run slower rather than faster, even on the examples that use constraints.
But I think that attribute values in my implementation is not attribute values that you think of.
Okay. So well, maybe you can tell us what you implemented. How did you implement it?
So originally it was default constraints when we do end unification and check all constraints that were before, where constraints are substitutions.
Okay.
And it was kind of slow. Because
you were checking every constraint after every successful unification.
And there was a remark that we, in every check, we should check only variables that exist in this constraint.
Yes.
And this is kind of optimization. This is you call attributed values, I think.
Well, okay. So the attributed variables refers to a specific implementation technique, which means that you can have attributes on the logic variables. And so for if you have a fresh logic variable X, then X can have certain properties on it. In particular, it can have constraints associated with it directly, as opposed to having just a big collection of constraints that you always check. Then you can have this logic variable X has this disequality constraint associated with it. It has this symbolo constraint or this absento constraint associated with it, whatever. And if X is involved in a unification and unification succeeds, then you can just say, okay, well, what are the constraints associated with X? Let me look at those and see if we have to solve those. That's the basic idea.
It sounds more like optimization when we store substitution in a variable.
Well, I guess it depends on how you do that. I'm not sure what you mean by solving or storing substitution in a variable.
I mean set-var-val optimization in FastRMK. When you store the substitution of a variable.
Oh, you're talking about the box thing, the local thing?
The thing with scope.
The scoping. I think this is totally different from the scoping thing. I don't think there's any connection.
But it sounds like attribute variables.
I don't think that has anything to do with it. Well, let me think. I guess okay. It has a similarity in that you have a specific variable and you're doing something with that. The intent, I think, is quite different. And so the attributed variables is like a general technique you can always use, whereas the other optimization is like, well, in certain conditions, when a variable is introduced fresh before you get a choice point, you can do this certain optimization, but it doesn't work in general. And that one I think is more like a specialized optimization, where attributed variables is just like, here's a way to implement disequality constraints. Even if it wasn't faster, you might want to do it just because it's maybe more convenient. Let's see. Michael says, are you having to filter the constraint store to find those that are relevant? Or are you using a hash map from variable to constraint information? No, all hash maps.
I just don't search relevant constraints. Because in FastRMK implementation, I think, we check only head of the list. If a constraint is a list of pairs, we check only a head of list. And if we still need to add something to the unification, to the substitution to make this constraint, make this pair equal, this constraint matter and should not be thrown away. So we do not check all the list. And this is kind of optimization about, okay, I will call it fast disequalities. I mean, fast disequality constraint implementation is faster MK. So it's not relevant searching a variable. Does this variable appears in this constraint? Because in this constraint we search only a head, and if head still be not equal, then we should not check the tail of the list. Is kind of sound sane or not?
Okay, you made the optimization you just described and made things slower? Or am I misunderstanding the problem?
Yes, it made it slower. I can share the same graph with histograms like 3 hours before with Will and another Dmitrii. And sound has been lost. I don't know it is only me or all guys.
Okay, so I think there's a separate issue that maybe we haven't talked about yet. So within a single disequality constraint, we can end up having multiple pieces of that unification prefix, as Orchid was saying. So, you know, if we were unifying two pairs, then maybe we'll have different parts of the disequality about the different parts of the pair. But that's a single disequality constraint, right? And there are potentially many disequality constraints if you've used disequality in different places. So the other question, an important part of the point of this optimization, is how are you representing the overall set of all disequality constraints that have ever been applied in the application? Is that just a big list, or is it a mapping from logic variable to disequality constraint?
It is a list.
Okay, so that's sort of the problem, I guess. The point of doing disequality the way we were doing them was to make it so that that instead could be a hash map from variable to disequality constraint, if that makes sense. And that way you don't have to walk through the entire set of all disequality constraints when most of them are probably irrelevant to the variable that you're considering.
So it is kind of two parts of optimization, yeah?
Yeah, so the reason for only looking at the head of that list of constraint pieces is that we want to attach the constraint to as few variables as possible to make sure that if we're doing a unification and we look up in this hash map to see, well, do we have to consider this constraint? We want to see that as infrequently as possible. Most of the time we want to look up in the hash map and find there are no constraints that are relevant.
Okay. Well, I need to fix my code. It is very inviting.
But does it make sense that sort of that's the point there, is to turn this linear walk over the constraint store into sort of a constant time hash map lookup to find just the constraints we care about?
I didn't parse this question.
So, okay, so I'm saying that the purpose here is that previously, right now, you're doing this linear walk over the set of all disequality constraints. So you've done 1,000 disequalities in your program. Now you have to do this linear walk over all 1,000 of them, right? Even if only like 2 are relevant.
Yes.
So we're trying to change that into a constant time or logarithmic time hash map lookup, where you just look up the variable and find the particular constraints that are relevant.
So I don't have this at the moment in my implementation. It will speed up things, I think. Okay.
Orchid had a question for you, Michael, and this is a question that Chris asked me last week. Well, I guess for you too, Dmitrii. So how are you in faster miniKanren and OCanren? How are the disquality constraints implemented? Is this based on this technique of doing unification and checking the prefix, or is there a different way of it?
Yep, it's that.
Okay. And Dmitrii, are you doing the same way?
I think so.
Okay. Because there are sometimes, there are. Well, do you know, does CoreLogic implement it that way, or does CoreLogic use a different approach?
I don't know.
Okay. Anyway, I know there are other ways of implementing disquality constraints. I'm just not sure.
I know CoreLogic doesn't do the fast attributed variable stuff that I'm doing on Untitled. But I think they do implement it by just trying unification and seeing if it succeeds. So they may not be. Yeah. I don't know if they're like recording the prefix or not, because you could just always reapply the original disequality, right? Instead of recording the updated.
That's right, and in fact, that was the way Dan and Jason were doing it. They weren't trying to simplify. I think they were doing it that way. They're like,
my version's recording that prefix so that it knows what to attribute.
Okay. All right. Yeah, I hope we can get Chris on here soon to talk about his work on semi-unification also.
He's still progressing?
Seems like,
Good.
Yeah. Oh, hey, Greg's here. Hey, Greg. I was just going to say, I wish Greg was here. I think Greg would be interested in some of the things we're talking about. So Greg, you missed a very interesting discussion. Daniel was talking about his ideas for doing reinforcement learning. So you might want to watch the beginning of the Hangout again when it's online. And Evan sent me an email saying he's traveling today, so I think he would also be very interested in, and also Rob, if Rob's available. Rob, I think would be interested in maybe could get some good feedback on that. But so Daniel thinks that we could probably use reinforcement learning over sort of a reified version of the search tree, where we actually are, instead of just having the search tree be implicit, if we actually create the search tree as we're building it, we could do some reinforcement learning on that, and that this also might be quite amenable to the sort of thing where miniKanren could learn on its own. Instead of having to have a giant corpus of scheme code, we could get miniKanren to kind of play against itself, if you want to think of the AlphaGo analogy, which would be very powerful, because then we could just throw massive amounts of computational power and learn these things. So yeah, I'm really excited about that. I'm hoping we can start prototyping this. I guess there's another thing I want to do. Well, I've got a whole bunch of things on my to-do list, but one thing that I'm interested in doing is looking at. Okay, so fixing that bug. It wasn't an intentional cheat on my part. That was just a bug with the crude learning I did, and seeing how that affects the running time. So yeah, I need to take a look at that. I will point out that the Scheme Workshop deadline is the 16th, I think it is. It's Friday, right? So everyone's got their Scheme Workshop papers ready, right? Orchid, you got your paper ready? And I was thinking, if I were to submit a Scheme Workshop paper, what would it be on? And I guess one thing we could submit a Scheme Workshop paper on would be that. like a cleaned up version of that crude learning. Right? I mean, that's not a POPL paper at this point. I think that might actually be a quite fine Scheme Workshop paper. So I was thinking, should I write a Scheme Workshop paper on Monday and Tuesday? I know Greg and Michael, you all helped clean that up. So I don't know if you have any interest in going on a quick, it's only 6 pages, so we could, it could be a POPL paper someday. So yeah, I could. I think we'd probably be okay. I think the POPL version of it would be different enough, but if we think it's actually interesting enough that that is, I guess probably less interesting than the crude learning is, we used one of Greg's optimizations. Well, that optimization we talk about in the Perl too, though. So I guess that one's not completely new. Anyway, just throwing an idea out there. I'm not wed to the idea of doing that, but we could, I guess we could show that as if we have a more detailed, nicer version of the learning, I guess we could turn that into a nicer paper. I guess my current mental model is that's a Scheme Workshop paper, not like an ICFP paper, but maybe we can keep pushing it. I don't know. So Orchid, what have you been up to? You got any new problems or challenges or programs you've been writing? Not much computer stuff. Well, it's good to get away from the computer sometimes. What have you been up to, Greg? Other than our artifact. Working towards a self-applicable supercompiler. Wow. Okay. Is this the ACL2-ish thing? Not that ambitious yet. Okay. All right. In that direction. How's that going? Is it? Slowly. Okay. Yeah. Every time I hear the word supercompiler now, like it sounds tricky. Sounds tricky. Maybe it's one of these things like abstract interpretation. Yeah, we should do a hangout on that. Any new thoughts on DCanren or on we talk about maybe doing some speed ups to the current interpreter or anything like that? Or are you focused on the super compilation stuff? I haven't worked on DCanren in a while, but I've started some transformations for making the current interpreter faster. The problem is it's getting complicated again. Yeah, that's the thing, right? Are there people working on the super compilation stuff on your end, Dmitrii? Is that something that has to be revisited?
Well, I think you remember Catherine. She
Yeah.
appeared. So I was told that. So I know that she's now in Dublin. And
London?
Dublin.
Oh, Dublin. Oh, okay, cool.
So there is a professor there. I don't remember his first name or last name. Actually, I don't remember both. So he probably is Googleable, but some words like how it's called when you super compilation with distillation. What?
Okay.
So it's kind of technique to super compile some code, and you get a huge graph from it, and you can wrap some recursive calls in the loop to make a graph, not countable but finite. Well, this is the idea. So this approach to transforming programs can give you a super linear speedup. Even this approach can take a very straightforward quadratic Fibonacci and invent an accumulator in it.
Oh, wow. That sounds very powerful.
It is done for very Haskell-like small language, but the sources of the approach, I was told, are not open. You kind of send a program to a professor and does some stuff and gives you a result. So the main purpose of Katrin is to understand what is happening there.
Okay.
And the rumors say that we can take this approach, take appendo, and distillate them from it a normal append in ML, and the reverse execution of append that does two kinds of distillation.
So are you saying you could write the miniKanren program and get out like an ML program that runs backwards?
And distillate two programs that runs forward and backward. As far as I understand, nobody did distillation from one language to another language.
So that sounds a little bit like what Curry. Oh, sorry. Well, maybe Curry can do it, but it sounds a little bit like Mercury. The Mercury compiler, you can write something that's kind of like miniKanren, and it can turn into ones that run forward and backwards. I wonder if there's any connection between sort of the Mercury techniques and this sort of technique.
I don't know. I just said you some rumors about Catherine.
Okay. Well, that sounds cool. Well, if we do a hangout on super compilation, we should definitely invite Catherine. So she might be interested in this or want to talk about it a little bit more. Yeah. So, and I'm excited to see what Greg comes up with. Also, and all these things sound very, very powerful and very interesting, and also maybe tricky. They sound not so simple, maybe, to implement, but we get better over time. We learn these things, right? So distillation is like super compilation, but does generalization on the entire graph rather than a single node in the graph. You can also take quadratic reverse and turn it into linear reverse. Wow. Can it do anything with sorting, I wonder? Can it take bubble sort and turn it into quick sort? That would impress me. I suspect it can't, but that would be neat.
You can send a program to Dublin.
Send a program to Dublin and we get that quick sort. On punch cards, yes. Sent via carrier pigeon. Well, there are these attempts to automate biology, molecular biology, and one approach is with robots. and you upload your experiment, your biology experiment, and then the robots perform the experiment. And then there's another approach where you also upload a description of your experiment, and it's performed by robots, but the robots are undergraduate students. And it's yet to be seen which of these approaches will win out. Yeah, Mechanical Turk, basically Mechanical Turk with graduate students doing molecular biology experiments. Yes. So Barlaman actually, is Mechanical Turk. We just haven't told anyone. That's why it's so slow. What I'd like to see is more miniKanren programs. We got some really fun stuff like append, Oleg numbers, logic puzzle solvers, evaluator, map, coloring, Barlaman. What next? I like the joke that Barlaman sends programs to me, says Greg. Okay, well, that's a good question, Market. Well, you did the MIPS assembler disassembler. That was a fun one. Well, I guess there's, well, okay, so there's type inferencer, which we're trying to get better at writing, partly through the improved unification. Yeah, that's a good question. What other problems, what other programs are fun to write? Well, I don't know if I mentioned this, but I was able to run Barlaman. I was able to run microKanren in the relational interpreter in Barlaman. It was quite slow, but I was able to do that. I don't know if that counts. I mean, I guess once you have the scheme interpreter, then you can take any scheme program and run that, but it's still kind of slow. What other fun programs are there for logic programming? Well, one thing I'd like to do is expert systems. Some expert system-y thing, or interactive fiction. Interactive fiction would be fun. In fact, originally, I was trying to implement defeasible logic. Maybe defeasible logic plus linear logic equals, relational interactive fiction. That would be cool. Let's see, what else? There's Evan has been thinking about ideas for doing like an operating system in miniKanren, a relational operating system. We've also talked about ideas for doing, like graphics or interactive graphics in miniKanren relationally or things like that. I mean, that's actually the first version of Barlaman came about. Well, the pre-Barlaman prototype in Racket came about because I saw in the Brett Victor demos and all that, and I also saw Alan Borning's work on things like ThingLab, and then his more recent work on sort of a geometric constraint solving in real time at 30 frames a second or whatever, like a ball bouncing around where it's actually doing constraint solving, calling out to Z3 or whatever 30 times a second. I thought that was really neat. So I was trying to figure out, well, what would be like the miniKanren relational equivalent? Because I wanted to do things like graphics in miniKanren. And I couldn't figure out how to do it. Greg says, computer vision via running a ray tracer backwards. Now, that's a really interesting idea. If you could run a ray tracer backwards, and there has been work, there's been, statistical work from MIT on doing things that are kind of like that. Michael and I saw a demonstration of basic, something very much like that, right? Michael, do you remember the name of that system? I'll have to see if I can find it, but it's synthesize a ray tracer from scheme output and image output. Yeah, it was a probabilistic programming language that I think it was maybe Venture, but it's one of these languages that is sort of like in the church family, that would let you take a scene and it would try to figure out like the code that rendered that scene. Which was pretty cool. Let me see if I can find that right now. I think I could find it pretty quickly. MIT probabilistic computing project. I think that's probably it. See if I can find it. Yeah, I think this is Vikash. Vikash's work. Publications. Probabilistic data analysis with probabilistic programming, blah, blah, blah. Oh, here it is, maybe. Is it Picture? Picture, an imperative probabilistic programming language for scene perception. I wonder if that's the one. Let me look at that real quick. It was pretty cool. I don't know if that's it or not. I can't tell. Anyway, there's been some very interesting work on using probabilistic programming to try to do things like take a scene and figure out which code was used to render it and so forth. And we'll have to see if we can dig up the demos for that. So actually, you know, this is one of the things that Rob Zinkoff has pointed out, and other people have pointed out. You know, it's like, well, I guess there are two things. You know, Nada sent me some links recently. It was like, okay, so there are connections, right, between logic and probability. In fact, you know, there's this work by E.T. Jaynes, Jaynes, that talks about probability as an extended logic. Probability theory is an extended logic. So there are connections, like deep theoretical connections between logic and probability. And the other thing is, if you do probabilistic programming, I've been told this over and over again, or heard this over and over again, is like probabilistic programming languages let you run backwards and do things like that. So, you know, you can try to infer missing information in a way that's kind of similar to what we do. I mean, it's a totally different technique, but with running backwards and whatever are actually sorts of things that you can do with probabilistic programming. So that's why Rob and I were interested in trying to create some sort of hybrid probabilistic logic language that was kind of miniKanren meets Church or Hakaru or whatever. Yeah, it'd be neat if the approaches could complement each other. That's exactly right. You know, so we've tried this a couple times, and I think I just don't know the probabilistic logic programming stuff well enough, and I think it's you're just like learning all of the details of miniKanren and how to use miniKanren and how to optimize miniKanren. Like, there's a lot to learn there. I think it's kind of similar space, if not harder, with probabilistic programming. And, you know, at least with logic programming, people have 40 years of trying to explain it to people, right? And there's like a ton of textbooks out and stuff like that. But the new generation of probabilistic languages are really still being written. And I think it's not so easy to understand it if you don't already know that space really well. So what would happen is Rob and I would implement something, and we start doing examples, and then we'd realize, like, oh, well, we need this feature for this example. And then it's like, oh, this feature is actually such a big change that we kind of have to redesign the system from scratch. So we did that multiple times. And I don't know, maybe we were getting close to a fixed point, maybe we weren't, but it was it was like, okay, now we have to redo the whole thing. Now that we've learned this, that we need to add this feature, right? What's the biggest feature barrier? The biggest feature barrier is not knowing which features are actually necessary, I think. You know, it's like, I think part of the problem is, like, Rob didn't know all the details of miniKanren, and I didn't know all the details of, like, Hakaru. And so we would go along and implement something, and then we would realize, okay, so where's the last place we got stuck? The last place we got stuck was, there was a very particular thing we got stuck on. What was it? So the first thing we got stuck on was tracing. I didn't realize that we had to keep a trace of all the program executions at all points. So that was the first thing we got stuck on, and then I added that. And then we got stuck on something. I think we went through this like 3 times. I'm trying to remember the last thing we got stuck on. Oh, I remember what it was. We got stuck on the problem of recursion. So the problem was, if you try to do the probabilistic programming the way Hakaru does, which apparently is like the clean, nice mathematical approach, at least at the time, which was, I don't know, year ago or whatever, year and a half ago, they didn't actually have a story for recursion. Like, they couldn't calculate the probabilities when you went through a recursion. And, you know, of course, everything we do in miniKanren that's interesting uses recursion. So that was kind of like, okay, if we can't handle recursion, I don't even know what to do, because, you know, and so we're kind of where we left it was, okay, they were doing some theoretical work to try to get a better understanding of the exact semantics for recursion. Is it using Metropolis Hastings? Well, you can use Metropolis Hastings. I think you can even do exact inference for some of the problems. Metropolis Hastings was one of the things we were implementing, and you know, so apparently some of the other probabilistic languages work fine with recursion in some sense, but you know, I guess it depends on how persnickety you want to be about the exact semantics and getting the exact probabilities right in every case. And so it sounds like, you know, there's some ways where you can kind of either cheat or get away with it most of the time, or maybe have a very restricted version of recursion, or maybe do some sort of estimate. I don't really understand the technical details, but apparently, at least with the Hakaru approach, to do full recursion, to get all the probabilities right in every case, was still an ongoing research problem, which was something they were working on. So I should check with Rob to see if that's something that they've solved. So, but that was kind of the showstopper the last time. It's like, okay, well, if we can't handle recursion, then yeah, we're out of luck. I kind of don't see, you know, we're not going to write in a relational interpreter if we can't do recursion. And like I said, I never fully understood why this was a problem. And for some other probabilistic languages, they don't seem to have a problem with recursion. But maybe it's because other, you know, it seems like with these probabilistic languages, every language has its own view of things, and it seems like for whatever reason, what Hakaru was trying to do, and I think part of the reason they're trying to do exact inference in some cases. The Hakaru approach, it was more complicated, or they were trying to be, you know, more formal or more precise or something. So I'm not sure. So we could ask Rob about that, but that's kind of where we got stuck last time. So if they've solved that, then that's something that's worth continuing to explore. I guess in the short term, at least, it seems like the things with neural networks and learning sound probably like those are probably things that are going to have a bigger payoff short term. I think the Hakaru, you know, trying to combine Hakaru and miniKanren is just tricky because Hakaru is still very much under development, or at least it was at the time, and they were still trying to figure out the semantics of it and things like that for certain things like recursion. So part of it may be just like, well, we just have to wait a little bit until Hakaru is kind of settled, and then it will be easier to do. So anyway, it was fun hacking, and I definitely learned something about it. But it also seemed like, yeah, this is pretty tricky. This is pretty tricky stuff to get it working right. And then, you know, to really do it right, you have to prove that what you've implemented actually is meaningful from a probability distribution standpoint, and all the semantics are right, and there's a lot of work in making a probabilistic language that's decent, and all. The other thing is that what we were implementing, I think, was probably going to be dog slow, because our inference was not very good at that point. So this I think is at least a medium-term project to combine those two. All right. Any other ideas for fun programs to write for miniKanren? What other fun miniKanren programs might you have? Well, okay, so like I said, was, can you imagine something like an operating system in miniKanren? Can you imagine something like, oh, here's another thing, a distributed miniKanren? Can you imagine a parallel miniKanren, or a can you imagine, so the operating system thing's kind of interesting, actually, because miniKanren's implementation is already kind of an operating system, right? We basically have the scheduler, and when you do a conde, it's like you're running two different computations in parallel and different threads, and or different processes, and they can't talk to each other. They have different address spaces. There's also this concurrent programming, or concurrent Prolog language that you can use to write operating systems and things like that. Alan Kay has said that he wasn't very impressed with Prolog, because if you can't write an operating system in it, what good is it? And so that's sort of a challenge. Like, what would it take to write an operating system in miniKanren, or what would that look like, or what would be interesting about it? Or once again, graphics or interactivity. I guess this is the theme. How do you do something in miniKanren that's interactive? Everything we do is basically batch processing. We're running one query, and then we get the answer, right? But if you wanted to do something that's more interactive, how do you do it? So Barlaman is an experiment in that way. So we basically, with Barlaman, every time you type a character, it's going to run the queries again. So that's one model of interaction, and that's actually what Alan Borning's most recent work with Wallingford is doing something similar like that. It's calling the Z3 solver 30 times a second or something like that. So we could do some model like that where we're just calling miniKanren over and over and over again. So it doesn't really have to be interactive. We can kind of fake interactivity that way. But what would it be like to do interactive graphics? Or what would a Barlaman video game look like? I mean, if you look at Idris, Edwin Brady gives these Idris demos, and he says that people talk too much about being Turing complete. That what they should really talk about is, is the language complete for Pac-Man? Is it complete for Space Invaders, right? So he gives demos in Idris of Space Invaders and Pac-Man. Is there a video game that you could write in miniKanren that would take advantage of the relationality? Is there anything there? I don't know. So that's a challenge, I guess. That's a challenge is, can you come up with something interactive that uses the relationality? So Barlaman is one example of that. So for synthesis, and in some sense, everything we do in miniKanren is a form of synthesis. So Barlaman is an example that you can have an interesting program that's interactive to some extent. It's not as interactive as I'd like it, but has some interaction with the user, and you kind of hidden the miniKanren details under the hood, and it does something very interesting because of the relationality. The synthesis, it can prove that tests can't run correct, or are inconsistent even with partially specified code. So what other programs can we write that are interactive, or how can we make more interactive programs that have graphics or video? There are video games or operating systems or whatever. A simple way might be adding an iConde operator which the user gets presented the options to pick from. Okay, so it's sort of iCondi is like interactive Condi, and it stops and presents the user with all the choices, and they get to pick, right? Yeah, I can see that. I mean, I guess I could also see that, if you want to do a text adventure game, you could use something like that, right, to interact with the user. So that would give you a way to give input. That's right. If you had an operator like that, I guess the question is, what would you use it for? What would be an example program that would be interesting, that would take, that would actually use the unusual features of miniKanren in an interesting way. So obviously we could do something like try to just encode a regular program, a regular scheme program in miniKanren and just run it forward. But that seems kind of, that seems a little pointless in that it's like, well, okay, well then just write the scheme program. So in order for this to make sense, I think there's got to be something about it that uses the features of miniKanren. So anyway, that's not an answer, that's a question. But I think it's an interesting question. I think it's worth thinking about is, what can we do that's more interactive, or what would a miniKanren operating system look like, or what would a miniKanren video game looks like, or, could you, what other things could you do in miniKanren or in DCanren or something like that? If you had DCanren, maybe it's easier. I don't know. Could you write an operating system in DCanren? I don't know. But that's I think a fun problem to think about. All right. Anything else?
I think I have some maybe interesting topics.
Okay.
So I was discussing this. It's not like interesting, but more practical. We have a guy who is teaching graph algorithms course in the university, and he is struggling from generating new exercises for students. So it kind of will be interesting if miniKanren can enumerate all the graphs, and more precisely enumerate all the graph recycles, and we can convert a number of the graph, index of the graph, to a task number, and give a students a task number 15,003, and it will be a task about finding a cycle in a graph, and miniKanren can generate the task and also generate probably a solution. It is not obvious for me how to implement this, because the first way is to enumerate all the graphs and filter out the bad ones, and will be kind of slow. But another approach is to generate, for example, a cycle and add some meat around it. And the idea how to add some meat is not obvious how to implement for me at the moment, because we don't have a constraint. I think give me a term without free variables.
Oh, I see. Okay. So you're saying you want it to be ground?
Yeah. So it is maybe interesting, but it will be more practical than interesting. Well, we can write some useful programs in miniKanren.
Well, this also, something similar comes up with the educational uses for Barlaman. The folks at Cornell who are working on Galadriel. So Molly and Yiting and the other students working on that, they want to be able to do similar things. In particular, they want to be able to say you have some program like append in Scheme. They want to be able to also do things like generate input-output examples from the program itself, which would be another educational use that would be handy. And in fact, that might be one way to solve the graph problem. I don't know if we could do it quickly enough, but this is something we've looked at with Kyle on testing. Is if you could write in miniKanren, if you could write a miniKanren predicate that accepts a graph that has the right properties, then the acceptor can also be used as a generator. So in other words, you have you have some miniKanren goal that will only succeed if a graph has a certain structure, right?
Yeah, but we still have a problem about free variables with this generator.
So what is the problem again? So that you want to generate graphs that are ground, and you're afraid that it'll have free variables in it, or fresh variables.
In this approach, we will generate a circle, for example. No, not circle. Path, not chain. How you call it?
Okay.
Cycle.
A cyclic path. A path with a cycle in it.
And some meat from fresh variables around this cycle, and that this meat should be substituted into something ground, because if you present this graph with three variables to a student, it will be easy to solve.
Yeah.
Cycle.
Yeah. Well, you might have to have a separate grounder, and this is something that comes up a lot in logic programming. Excuse me.
Bless you.
This comes up in things like I think in like answer set programming, stuff like that. There's this, they'll have a special program called a grounder that takes logic variables essentially and can give them ground values that are consistent. So that might be one way to do it, is to generate values that are, or generate answers that are, even if you generate answers that have some of the structure but not all the structure you need, I wonder if you can then do a grounding step. You could also probably do a grounder as a miniKanren program. I'm not sure, but you're right. I mean, it is interesting. There are ways to detect in miniKanren if a variable is fresh. They just happen to be non-relational. So you can use project, and you can use cond A and cond U. And in fact, we do this in the reason schemer. So there are times where there's an example of a program in the reason schemer where we do something kind of like this, where you run the regular miniKanren code to generate a partial answer, and that partial answer might contain variables in it. And then you have another step in miniKanren that goes through the answer, and it checks to see if you have any variables that are not ground yet, and you can actually then ground them. So you can implement that in miniKanren, although for this particular application, it might be tricky to get it to work in a way that's interesting. I'm not sure.
Mm-hmm. So I have some interesting SMT solver related stuff discussed. So my friend is very into these heuristics about in the core of Z3, I think, at the moment. And he patched something, I don't know for sure. And he wants to kind of write heuristics that will prove programs to be decent. When we say proof, I mean we take first part of a book, Software Foundations by Benjamin Pierce, in Coq. And we write append function in it, and we write call Z3, and he kind of proves this. And he wants to measure his future heuristic prover based on Z3 with miniKanren, who enumerates all the possible proofs and tries to, with brute force, to prove that, I don't know, that plus on piano numbers is associative.
Okay, so I'm not sure I'm completely understanding this. So what miniKanren, would we have a theorem, or would we be implementing something like Coq in miniKanren, or a theorem prover in miniKanren and then enumerating all?
we will,
all proofs in that theorem prover, or is there?
in relational style, like we do with scheme program, we can, from the input, where input is theorem definition, for example, piano numbers are associative operation, plus is associative operation. We can try to enumerate all possible proofs. I mean, in the manner like we enumerate all possible programs.
Yeah.
And we can, after some years, enumerate the right proof.
Did you see the updated theorem prover that we have in the Perl that I sent you? Because Greg has been able to prove some interesting, well, I mean, some somewhat interesting things. Like Greg, what are some things you were able to prove with the miniKanren relational theorem prover? Transitivity of implication, commutativity of conjunction or and. Well, you're right, Orca. That is a good example of interactivity. If we could do like an interactive theorem prover or proof assistant in miniKanren, that would be really cool. That could also do synthesis, right? And in fact,
is this prover about Boolean logic?
What is in the prover that you implemented, Craig? It's just a logic and implications. Yeah, so it's a propositional logic with implication and a couple other things. Modus ponens, use assumption. So it's it's a pretty weak. It's a pretty weak prover. We have another prover though. We have a prover for first order logic. For predicate calculus, and that's the paper in Alpha Lean Tap. So we have this paper with Joe Neer was the first author on Alpha Lean Tap, and that paper has a lean tableau theorem prover for first order logic, and we implement that as a relation using nominal logic. And Joe thinks that we could probably at this point take that prover and implement it in our new version of miniKanren, and probably do better for synthesis than we did back then. I think he's probably right. So we probably can do a theorem prover for at least predicate calculus type things.
Does this theorem prover requires OCanren?
That one currently does, unfortunately. But like Joe says, we probably can implement that in the same way that we've implemented this other theorem prover. I don't know how well it would perform, but yeah, I mean that one does require OCanren. So that's the unfortunate part. That's why we haven't really used it. But I would like to go back and take that theorem prover or some other theorem prover. I mean, the other thing is type inferencers are theorem provers. So we've implemented a number of type inferencers which can prove theorems as well. But anyway, I'm curious to see what. So for what logic does your friend want to prove these theorems?
He wants to take a Coq programming language with constructive logic. Yeah. It is not Turing complete, but you can write append here, algebraic data types and stuff like that. Monads, dependent types, and a lot. So I think the main issue with this, with proving, with brute forcing Coq proofs is that I think sometimes you need to introduce some lemmas. And I'm not sure, is it possible to prove something without introducing lemmas?
There's this field of inductive logic programming, and they have that problem, which they call predicate invention, of exactly that, trying to invent lemmas. And so you might also want to look at that work, if you're just interested in that problem in general. But this is something we've wanted to do with Parliament as well. Invent helper function.
Can you repeat, please?
So there's a type of logic programming called inductive logic programming. I don't know if you've heard of this, ILP, inductive logic programming, as opposed to deductive. And the inductive logic programming researchers, including like Stephen Michaelton, they've been interested in this problem, and so they can do synthesis as well. They use a different technique, but they're interested in this problem, which they call predicate invention, which means basically inventing a lemma, the equivalent of inventing a lemma when you're doing synthesis. So they've put in some work in that area. And that's one of the things we want to be able to do in miniKanren is in Barlaman is if we're trying to synthesize a function to synthesize the helper function. It's this similar sort of idea, right? Where you have to invent a helper. Well, it'd be interesting. I don't know how hard it would be to implement, the logic for cock in miniKanren. I know people have implemented dependent types, the type inferencers, and dependent type checkers in miniKanren. And I'm curious if we could do something like that, and how well it would work. My guess is to make it work well at all, we would probably have to use all the sorts of tricks that Greg's using with Barlaman, all those sorts of optimizations to try to make it, to make it at all feasible performance-wise. But I don't really have a good sense of how hard it is to implement that logic. Do you know, or do you have a sense of how hard it is to implement something like cock?
No, I don't know, but I don't think that dependent type logic, dependent types, and type inference for this, it is interesting to implement, because as far as I understand, it is undecidable.
Yeah.
And you can easily run into some program that you can type check, and you can't understand that it makes no sense to try to type check it.
Yeah.
There are a lot of useful stuff in decidable ML style type checker. We should stick there, I think.
Yeah, so right now there's a graduate student, Chris Brooks, who's working on doing an ML style type inferencer in miniKanren as a pure relation, using a type of unification that's related to semi-unification. So we're trying to get that to work so that we can. So the problem is right now we have not figured out a way to implement the let polymorphism in a way that is both relational and actually matches all the rules of ML. We can kind of fake it, but we've not figured out a way that's both relational and actually gives the correct types for all the terms. But it looks like this variant of semi-unification should be able to do it, we think. We're not 100% sure. So that's a project we have going on. So if that's true, then we should be able to do things like write a Barlaman, but for ML that's type directed, which would be really nice.
And probably the last idea about fun or not projects about miniKanren, as far as I remember, there's Z3 engine which have under the hood Muset, the engine to introduce inductive variants about some functions.
So try to infer invariance. Is that what you mean? What you're talking about?
Which invariance? No.
Are you talking about proving invariance, or are you talking about like inferring invariance automatically?
Kind of inferring.
Yeah, okay.
For example,
so like invariant discovery or invention or whatever.
For example, when the output of Fibonacci function should be more or equal its arguments.
No. Okay.
When you write Fibonacci in when you remember the last two elements
Yeah.
in this style of Fibonacci. So maybe we can unleash this engine into miniKanren and introduce some invariants which will help miniKanren to finish when no more answers will be received. For example, do you remember this example from your thesis when you explain why tabling will not solve anything? The example about multiplication.
Yes, where the terms keep getting bigger.
If we somehow will be able to introduce some invariant which bounds these terms, and we will say that to get good answers, these terms should correspond, we'll stop the search and finish. It will be kind of good.
Yeah.
It is like a crazy idea that somewhere in my mind. Maybe you can.
Well, I guess the thing that reminds me of is for the relational arithmetic, which is in chapters 7 and 8 of the book. Sort of the Oleg Kiselyov came up with this relational arithmetic system, and the part of it that was hard to write and is very clever is, Oleg had to write down the sort of the algebraic rules for multiplication and addition and all that, and he had to figure out how to integrate the bounds on the sizes of the terms. Like, okay, this number will never be twice this other number, so therefore the list of binary digits will never be more than one digit longer and stuff like that. So he came up with all these properties, but then even after he had the properties, and the idea of those properties was to cut off the search, which is similar to what you were saying. So he wanted to cut off the search or bound the search. Part was he had to add the bounds to the miniKanren code in a way that wasn't going to cause problems with divergence. Because if you're not careful, you can add the bounds to miniKanren, and it can actually, the bounds themselves can make the program go in an infinite loop. So adding those bounds and integrating the bounds into the code was really, really tricky. So if there's a better way to try to do that, to say, hey, there are properties we want to externally enforce outside of miniKanren, that would be very useful. I wonder if there's a way. I wonder if something you could do is like super compilation or any of the reasoning with ACL2 that Greg's interested in, or if something like DCanren's reordering of clauses helps, but that's something that's turned out to be very, very tricky to implement.
I am kind of out of ideas.
Yeah, I'm out of ideas too. Might be time for some dinner or lunch.
Or sleep.
Or sleep. Or sleep. Sleep's good too. Or catch up on my email. Yeah. All right. Anything else? Going once? Going twice? Let's see. Yeah. Okay. Well, I think that's it. So if anyone wants to hang out and just talk for a couple minutes, that's fine. I'll stop the broadcast, and thanks everyone for joining. And yeah, as long as we have stuff to talk about next week, we'll meet. We'll see if Evan's free. He has some interesting things to talk about, maybe. And maybe Michael will be feeling better, hopefully. Okay. Talk to y'all later. Thanks.